In the early days of the space program, many at NASA dreamed of extending our reach outside of the boundaries of Earth. One dream in particular was to send a spacecraft to another planet to determine if life existed beyond Earth. This is where the idea for the Viking mission was developed. This extraordinary mission was not only designed to land on the surface of Mars to do basic research, but to also perform scientific experiments to search for life on the Red Planet. Planning for the Viking project began on November 15, 1968, but the actual missions didn't launch until August and September of 1975 due to the complexity and challenge of the project. The mission included two identical spacecraft, each consisting of a planetary lander and an orbiter. Their primary mission objectives were to obtain high-resolution images of Mars, determine the composition of the Martian atmosphere and surface, and most importantly, to conclude if life existed. In the summer of 1976, both Viking spacecrafts arrived at their destination. As they eased into orbit, onboard cameras began scanning for potential landing sites. After a favorable landing location was chosen, each lander separated and descended to the planet's surface. The landers touched down over 4,300 miles away from each other, making history by becoming the first mission to land spacecraft safely on the surface of another planet.
Well, when we landed on Mars, I was quite jubilant, especially jubilant when I knew after the second landing that we had two relatively successful landers. In fact, the experiments on both landers worked beautifully.
Before the Viking mission was ever launched, many people thought Mars might harbor abundant plant life and microbes living among its rust-colored rocks. But the two landers quickly dispelled these notions. The landers revealed a world seemingly devoid of life at all. In an attempt to conclusively prove or disprove life on Mars, the two landers conducted 3 biology experiments by remote control from Earth. One of the experiments, called the Labeled Release Life Detection Experiment, collected soil samples that showed signs of possible microbes, but the consensus of scientists interpreting the data believed that the findings did not prove that life existed on Mars.
We guaranteed it for 90 days, 3 months, and I think the lander landed and operated successfully for about 6 years, which was quite a surprise to me because I was familiar with the failure rates of parts. And it turns out that once a few failed, as they did on the way to Mars, when we got to the surface, we were relatively lucky and had very few failures thereafter.
Together, the two landers accumulated 4,500 up-close images of the Martian surface. They also collected more than 3 million weather-related measurements, including the first on-site observations of a global Martian dust storm. The two orbiters, circling high above the planet, snapped 52,000 images covering 97% of the Martian globe.
I was very thankful that I came to Langley. Those spacecraft were successful not because of me. They were successful because we had such a tremendous pool of talent here at the field, and I hope that can continue into the future. I believe research ought to go on. It's the best way to get your money back. You can't spend too much for research.
The data retrieved from the Viking mission exponentially increased our knowledge of Mars. Volcanoes, canyons, craters, and evidence of surface water for the first time became apparent from the orbiter images. The Viking mission proved to be one of the most successful missions in NASA history, forever changing our understanding of Mars. In fact, it's been said that scientists learned more about Mars in the first 5 minutes of the Viking mission than in the 500 years before.